Here we are going to be learning how to derive the equation of a line when given the perpendicular distance from the origin. That's perpendicular distance and also angle of that perpendicular line. So, this is the relationship. So, this P represents the perpendicular distance of that straight line from the origin. So, this is the straight line. Perpendicular distance from the straight line to the origin is represented by P. So we see that the equation of the line is in this form. The perpendicular distance from the origin of that line is equal to x cos alpha plus y sin alpha, where alpha is the angle that perpendicular line makes with the positive x axis, not with the positive y axis, positive x axis down here. And then we also know that the perpendicular distance of the perpendicular distance of the line from the origin is equal to negative c over this, where in the general form of writing equations of straight lines, that is ax plus by plus c equal to 0. So this represents, so a here represents the coefficient of x, b the coefficient of y, and c the constant. So we can as well do this. Now let's get into this video and let's get into examples and know how to just use all these things we've just written out now. Okay, we have that. Find the equation of the line whose perpendicular distance from the origin is of length 4 units and at 60 degrees from the positive x-axis. So here we have the perpendicular distance from the origin is 4 units, and then the angle that perpendicular distance line makes with the x-axis is 60 degrees. So we have that the form of the line when we are given perpendicular distance and angle of that line is x cos alpha plus y sin alpha. Okay, so we have to substitute x cos 60 plus y sin 60 degrees. Okay, from trigonometric ratios, we have that 4 equal to cos 60 is 1 over 2. And then sin 60 is equal to root 3 over 2. Okay, this gives us that we have 4 is equal to x over 2 plus y root 3 or root 3y over 2. So let's multiply everything by this denominator here. When we do that, we are going to have that the equation becomes, so we multiply everything by 2. The equation becomes 8 is equal to x plus root 3y. So we can as well go ahead and then write this equation in form of making everything equal to 0, or we can leave it this way. So this is that equation. Find the equation of the line whose perpendicular distance from the origin is of length 4 units, so P is equal to 4, and at 60 degrees from the positive y-axis. Now remember, when we started this lesson, we said that it must be the angle from the positive x-axis. So this means that if this was the line, this was the perpendicular distance P, then this angle given to us is 60 degrees from the positive y-axis. So the angle is here, whereby we are interested in this. So this is angle 90. If here is 60, that means here is 30. That means the alpha we are interested in is 30 degrees. So always make sure you get that the angle is not just positive y-axis, that it must be angle at positive x-axis, angle with positive x-axis. Okay, so now let's substitute. We have that this is equal to x cos alpha plus y sine alpha. 4 is equal to x cos 30 plus y sine 30 degrees. 4 is equal to x cos 30 degrees is equal to root 3 over 2. Sine 30 is actually equal to half. So if this was the denominator, we multiply everything by this denominator. We have 8 equal to root 3x plus y times 1, right? Y. So this is the equation. Let's solve one more to consolidate what we have learned. Find the equation of the straight line whose perpendicular distance from the origin is 3 units and its angle and is at an angle of 50 degrees to the positive x-axis. So alpha is equal to 50 degrees, positive x-axis. Okay, we write out the relationship. X, so x always goes with cos. That's how to remember this, and y goes with sine. 3 is equal to x cos 50 degrees sine 50 degrees. Now we don't have a usual fraction for this, so we are going to make use of our calculator to get what cos 50 is and what sine 50 is. So when we get this in a calculator, cos 50 is 0.6428, 0.6428. So we attach x to that value, and then sine 50 is 0.766. So this is the equation. So you can have it in decimal forms like this too. So this is it. At the beginning of this video, we noticed that there is this formula that we wrote, that perpendicular distance between a line and that's from a line to the origin is equal to this. So now this example begs us to make use of that formula. Calculate the perpendicular distance from the origin to this line that has this equation. Okay. Now this equation is comparing it with this form ax plus by plus c equal to 0. When we compare it, we know that a is equal to 4 because a is the coefficient of x, and then b is the coefficient of y, and c is the constant value, so it's negative 10, so minus 10. Right? We substitute. So that perpendicular distance is equal to negative c is minus, and c is minus 10 over the square root of a squared, that is 4 squared, plus b squared, which is 3 squared, okay, is equal to minus 10 is giving us a plus 10. 4 squared is 16, 3 squared is 9. This gives us 10 over root 25, because 16 plus 9 is 25. And then the square root of 25 is 5, so 5 divided by 5. We have that 10 divided by 5, sorry. So we have that p is equal to 2. So the perpendicular distance between the line that has this equation and the origin is equal to 2.